Okay, in section 4.2, we're going to be looking at some applications of direct proportion, and that's where you're just setting up a proportion like we solved earlier with two equivalent ratios. We'll also be looking at inverse proportion. So our first example is if we have 60 gallons of oil flowing through a certain pipe that takes 16 minutes, how long will it take to fill a 450-gallon tank using this pipe? So what you want to do is you want to pair the two items that are put together. In other words, if it's going to take 16 minutes for my 60 gallons, those are the two amounts that I'm going to pair. So I'm going to pair 60 gallons, and I like to include the units here because I can make sure that I keep my ratios in the same order, and that takes 16 minutes. So again, these two amounts go together. I'm going to form a ratio with those two amounts. Now, I am asked to find out how long it's going to take to fill a 450 gallon. Well, I've set my ratio up with gallons over minutes. I'm going to do the same thing since this is a direct proportion. The ratio is going to have gallons over X, and this is going to be in minutes. All right, so that's how I would set it up. Again, there's a couple of different ways you could do this, but you want to make sure that your units are consistent. That's why I like to kind of include them, at least put a letter to know what my units are going to be. And then again, we're just going to use our cross products. I'm going to multiply 60 times X. I'm going to multiply 16 times 450. So 60x equals 7,200 here. And then I'll divide both sides by 60 to get my answer of 120. And of course, remember, we're looking for time. That was the unit of minutes here. So, or I could convert that to 2 hours if I needed to. Now, inverse proportion is going to be a little different. If you're not told any different, you're going to assume that it's direct proportion. And of course, always use common sense. If you've got 450 gallons, of course, it's going to take longer to fill the tank than 16 minutes. So you should have expected your answer to be larger, in fact, quite a bit larger. With an inverse proportion, you should always see that somewhere written in the problem. So we have a length of a wrench that is inversely proportional to the amount of force needed to loosen a bolt. So again, here's the language I'm going to be looking for in my problem that is an inverse proportion. A 6-inch long wrench requires a force of 240 pounds to loosen a rusty bolt. Now, those two things are going together, but instead of writing them together as a ratio, I'm going to write them differently. So I'm going to set this problem with inverse proportion up. I'm going to write my 6 inches. It does not go, I'm not going to put my 240 here. It's actually going to go on the opposite ratio. Okay, so that's what we mean by inverse proportion. It's a relationship that as one amount gets larger, the other is going to get smaller. So we're going to try to find out how much force would be required to loosen the same bolt using a 10-inch wrench. So 10 inches, again, I want to make sure I'm consistent with my units, and this is going to be the amount of force that will solve the problem for a 10-inch wrench. So again, the two amounts that are paired together, 6 inches and 240, are now in opposite ratios. They're in the different ratios. I'm still going to solve it using my cross products. 10 times x is equal to 6 times 240. So 10x is equal to 1440, and x is going to be 144, and again, remember that's pounds, so that's my answer here.